This is the podcast for the journal Neuropsychopharmacology. I'm Cynthia Graber. Maladaptive aggression, while not a diagnosable neuropsychiatric disorder on its own, often presents as an important comorbid condition with other neuropsychiatric disorders. But while both men and women can and do display aggression, there's been a bias to thinking of aggression in both its adaptive and maladaptive forms as a male behavior.
And so because of that sort of historical human bias, the preclinical literature is even worse. We've almost exclusively looked at the neural mechanisms that are driving aggression and aggression motivation in male mice or male rats. And it's taken us a very long time to recognize that this is something that not only can we model in female rodents, but also that we need to model so that we have a better understanding of the sex differences that are driving these types of behaviors.
Sam Golden is an assistant professor at the University of Washington in the Department of Biological Structure and also has an appointment in the Center for Excellence in the Neurobiology of Addiction, Pain, and Emotion. He's one of the authors of a recent study on aggression in the journal Neuropsychopharmacology. It turns out that, in part because of these biases, and in part because there's been a common perception in the field that studying aggression in female mice is particularly difficult, the use of female mouse models has been severely limited. Advances have been made recently, however. The NIH has required studies to include both male and female models, and scientists have discovered that outbred mice, which are more like common household mice than the inbred mice scientists typically use for studies, are better suited to female aggression studies. Dr. Golden says there are two types of aggression that can be modeled. There's reactive aggression, where the mice react aggressively to intruders in their cages. And then there's appetitive aggression, where the mice are trained to press a lever that will allow an intruder to enter and allow the animals to enjoy the feeling of being aggressive. They can press the lever to let a mouse in and thus choose to behave aggressively. Dr. Golden, in your current study, you wanted to examine male and female aggression in both of these situations. So what did you do?
So there's two parts to this paper. The first part is, could we identify the sequences of attack behavior that are different between male and female mice under defensive or reactive aggression conditions? The first couple of parts of the paper are purely from reactive aggression in the home cage, where we take a male mouse and put it in with a male intruder, or a female mouse and put it in with a female intruder. And then we can videotape those interactions, or we did videotape those interactions, to score all the different behaviors that they exhibited during those resident intruder tests. And then we use something called a hidden Markov model to basically identify the sequences of these behaviors that were similar or different between the male and female mice during reactive aggression.
And what did you see? How did the female and male mice behave differently?
So there was one main finding that we were able to identify by using these hidden Markov models, which is that the male mice typically use something that we call a persistent attack state. I'm going to say what the females do because they do more and it's a little more interesting. The females, rather than show this persistent attack state, show something more akin to an intermediate attack. That is basically a sequence of attacks followed by investigation. And so at the end of the day, if we didn't know if a mouse was male or we didn't know if a mouse is female, just by looking at the patterns of how robustly and consistently and persistently they attacked versus how intermittent with investigation their attacks were, we could easily separate them between the male and female cohorts. I mean, it doesn't sound like a mind-blowing observation, but what it tells us at the end of the day is that there are nuances to male and female attack strategies that we previously have not investigated. And so that's sort of the lead-in to what future work is going to be doing, because now that we know that they use different strategies, we want to understand the neurobiology behind these different strategies. And that's work we're currently following up on.
And then what was the second part of the paper?
The second half is, now that we knew that the male and female mice displayed different strategies and sequences of defensive aggression, is we wanted to know if they also showed similar or different capabilities for appetitive aggression. And so to do that, we moved to that operant task and tested both the male mice and the females to see if they could acquire operant aggression. And then if they did acquire operant aggression, what level of aggressive behavior they exhibited.
And in this part 2, did you also see different strategies?
Well, part 2 is much more interesting because while we saw that both these male and female aggressive animals, so these animals were aggressive during that resident intruder testing. So we took those same exact animals and put them into the operant procedure. And as expected, the males learned to lever press for an intruder, and they would fight with them. And so they found it reinforcing and rewarding. But the females learned equally well. However, they did not attack at all. So even though the females had previously been highly aggressive under defensive aggressive parameters, when it switched to voluntary, they became completely non-aggressive. And this was very surprising to us. So there's a large sex difference there between these male and female animals, in that even though they're all equally aggressive under defensive conditions, when it comes to choosing to fight, when we give them the choice to fight or not to fight, the females opted not to.
So this was surprising. What are the implications of these findings for you? Maybe both for research and eventually for neurobiology, maybe even clinical care?
Yeah, well, first and foremost, it's acknowledging that we can, using reactive aggression, so this defensive aggression, absolutely study both male and female mice successfully, which, even as sort of intuitive as that sounds to me and you, in the field is not something that's typically done because there's been this dogma that it's really hard to study aggression in female mice. So right off the bat, we're hoping that this publication will sort of reinvigorate the field to more readily include female subjects in their aggression studies, because we know nothing or very little about the neurobiology between these sex differences. Moving on to the operant part, we could talk about this a lot. So, when we think about it, for example, depression, I'll go on a slight tangent, but bear with me here. When we think about things like major depression, there's always been this dogma that women have a higher sensitivity to depression than men, right? That they're more likely to be diagnosed. There was a paper several years ago that came out in JAMA Psychiatry that showed if we do something as simple as include inappropriate aggressive behavior as a diagnostic criteria for major depression, which it's not typically used, that actually ends up resulting in an equal proportion of men and women that can be diagnosed for major depression. And so these sex differences that we have really not explored at all, now that we're designing and developing behavioral preclinical procedures to get at them, will allow us to identify mechanisms that will hopefully be incorporated into these other diagnostic measures. And not just diagnostic, but now, for example, we can see that we don't find as much appetitive aggression in our female animals, at least using these procedures, as we do male. Well, that certainly also suggests that as we look at other neuropsychiatric disorders that have some type of comorbidity with aggression that happen in both men and women, we certainly need to better understand these sex differences there as well. And so our hope is that this type of work is going to contribute to that direction.
Fascinating. So where does this take you next on a research path?
So one of the things that we're really interested right now in identifying are the whole brain patterns of activity that are associated with these sex differences. So we've got these really clear differences where the male mice will lever press, right? They'll acquire the operant self-administration for aggression and attack. And we have the female mice that acquire the operant self-administration, but choose not to attack. And what we really want to do next is at the whole brain level, identify the sort of unique signature of brain-wide activity that underlies each of these two outcomes. And we're doing that in our lab using something called light sheet microscopy and tissue clearing, where we take the brains of these animals after they've gone through these procedures, and rather than have to slice them up into hundreds of slices and then do histology or other type of approaches to look at brain activity across the whole brain, rather than do that, we actually make the brain totally transparent. And by making it transparent and then staining it for various markers of neural activity, we can actually image the whole brain intact. So as a single volume using this light sheet microscopy. This gives us a map of all of the brain areas that are uniquely activated in male and female mice during this procedure. And so once we've created this map, what we're hoping is that we'll be able to identify some unique sort of non-canonical reward centers that we can hopefully target in the future, for example, to decrease that transition from adaptive to maladaptive aggression that we sometimes see in males, or even to better understand why there's no aggression in the appetitive aggression in the female population. So we're going in that direction now, but this is really, this is such an interesting finding that was so unexpected that we're still very much trying to identify the next steps.
This is the podcast for the journal Neuropsychopharmacology. To read the paper discussed in the podcast, go to www.nature.com/NPP. I'm Cynthia Graber.